We see different kinds of motion every day. We see the motion of cars, birds, the motion of the hands of the clock, the motion of a ball in the field of play, and so on. Have you ever noticed that some of these motions repeat themselves? But before we go on, let's consider the concept periodic motion. Periodic motion is motion repeated at equal intervals of time. Examples of this kind of motion are motions of a rocking chair, a bouncing ball, a swinging motion, the motion of the moon around the earth, and so on. In this chapter, we will be looking at a particular kind of repetitive motion called the simple harmonic motion. Simple harmonic motion is the motion performed by an object moving to and fro along a line. An example of this motion is that of the simple pendulum. When a simple pendulum is slightly displaced from its equilibrium position, it does not just return to the equilibrium position. It swings back and forth in a regular, repetitive manner until it eventually comes to a rest. Each to and fro movement is called an oscillation. What makes simple harmonic motion different from all other kinds of periodic motion is that the restoring force is proportional to the amount of displacement from the equilibrium position. This property can also be observed in the motion of a spring fixed at one end and the motion of a loaded test tube suspended in water. So, let's have a formal definition of simple harmonic motion. Simple harmonic motion is the motion under the influence of a force that tries to restore the body to its original position, and the magnitude of that restoring force is proportional to the displacement from the original position. Mathematically, we can express this as F is directly proportional to minus x. The minus tells us that the force is always acting in the opposite direction of the displacement. Remember, we called it a restoring force. Introducing the constant of proportionality, we have that F is equal to minus kx. This formula looks familiar, right? In fact, it is the same as Hooke's law if the oscillating body is a spring, where x stands for the extension of the spring and k is the spring constant. Simple harmonic motion is very important in keeping track of time in both the pendulum clock and the wristwatch. If the motion is periodic, then the period of oscillation is constant and hence can be used to measure time. Let's recap what we discussed in this lesson. In simple harmonic motion, the acceleration of the body is directed towards a fixed point, which is also known as the equilibrium point, and this acceleration is proportional to displacement from that point. Hope you got that. See you soon.